So here we're looking at bounds and finding upper bounds, lower bounds of certain values that are given to us. So in this example, as you can see here, S is given as 4.15, but it's been rounded to 2 decimal places, and T has been given to 3 decimal places, and that's 2.515. Now, the first thing that we're going to do here is we're going to find out what the upper bound and lower bound of each of these given values are before we can go and work out what the upper bound for the value v is. So what is this upper bound value for s, which is equal to 4.15? So what I'm going to do here is I'm going to just draw a little number 9 to indicate numbers correct to 2 decimal places on either side of 4.15. So I'm going to write 4.15 first. Just going to draw a number line here. And so if I've got 4.15 rounded to 2 decimal places, the next number correct to 2 decimal places would have been 4.16, and the previous number would have been 4.14. So S could be either 4.14, 4.15, 4.16, and so forth if it was rounded to correct 2 decimal places, but we're told here that it's 4.15 rounded to 2 decimal places. So what could the highest number have been to get to that number, to have been rounded to that? Well, if we look part way through it, the highest number, this would be the upper bound here. The upper bound would be this value. So what is this value between 4.15 and 4.16? The upper bound here is 4.155, and the lower bound would have been the number here. So what's between 4.14 and 4.15? That would be our lower bound, and our lower bound here, as you can see, is 4.145. So that's the first thing that we do. We determine what the upper bound and lower bound of a particular number is. So this was for S. Okay, S is equal to 4.15. So we now know the upper bound and lower bound for S. I'm going to do a similar thing to then find out what the upper bound and lower bound for T is. So that was for S. I'll just make a note here for S. Okay, so this was actually the value S. Now I'm going to do a similar thing for T. So I'm going to write down here T, and I'm going to draw a little number line for T. And so what is the value of T they've given us is 2.516 correct to 3 decimal places. So the next number correct to 3 decimal places would have been 2.517, and the previous number to that would have been 2.515, and these are correct to 3 decimal places. So what is the highest value that this could have been for it to be have rounded to 2.516? Well, the highest value could have been is this upper bound value for T, which is 2.5165. And then halfway between 2.515 and 516 is the lowest value that T could have been. Okay, and that would be the lower bound of that. So that would have been 2.5155. So now we've got the upper bound and lower bound value of T as well. We can go and focus on the calculation. The calculation is V is equal to S over T. So we want to find, remember here, the upper bound value for V. So to get the highest possible value for V, what calculations must we do? Well, we must do V is equal to, to get an upper bound value, we need an upper bound for S. So we need S upper bound divided by, we need to divide it by a small number in order to make that V as large as possible. So to get V upper bound, we need to do S upper bound divided by T lower bound. Notice here, it's not both of them upper bound, because when you divide by a smaller number, your answer becomes bigger. So S upper bound divided by T lower bound will get us V upper bound. So what is this V upper bound? Let's do the calculation now. V upper bound is equal to S upper bound, which is this value here, 4.155, divided by T lower bound, which is this value here, 2.5155. And so this will then give us the upper bound value for V. So we go and put that into our calculator, and that gets us 1.65 correct to 3 decimal places, which is what the answer needs to be, 1.65. So there's our answer here. Now when we're trying to work out the upper bound or lower bound, The operation really will decide whether we use the upper bound of one letter or lower bound, etc. So here we've got the four operations: multiplication first, then addition, division, and subtraction. Obviously there's other operations, but these are the common ones we're going to be dealing with. So in this case, if I wanted to find a upper bound, I would need to multiply two big numbers, i.e. we'd need to use b upper bound multiplied by c upper bound, because that would get me the largest possible value. If I wanted to work out a lower bound in this case, I would do b lower bound times c lower bound, as that would give me a lower bound answer for a. Now, similar with addition, if I want to get a large number for d, then I want to use large values of e and large values of f. So if I want to get d upper bound, I'd use e upper bound plus f upper bound. And if I wanted to find out lower bound for d, I'd use e lower bound plus f lower bound. Now, suppose I wanted to then go and work out the division here. So I want to find out the upper bound for g. So if I want to get the upper bound for g, I would need to use a large numerator. So I need upper bound for the numerator, h upper bound, divided by a small number, because when we divide by a small number, the answer gets bigger. So we want a lower bound for j. And likewise, if I want to get to g lower bound, then I'd need to use a small number for the numerator, so h lower bound, divided by a large number for the denominator, j upper bound. When you divide by a larger number, the answer gets smaller. So that's with division here. Now with subtraction, it works similar to division in that if we want to find out k upper bound, we need to use a large number to begin with, m upper bound, and we need to take away a smaller number from it, so n lower bound, and that will get us the largest possible value for k, i.e. upper bound of k. And if I want to get k lower bound, I would use a smaller value to begin with, so m lower bound, and we would subtract a larger value from it, so n upper bound, and that would then give me the lower bound for k. E is equal to e over t, first of all, we're given, and we're told that e is correct to three significant figures, and that's 812, and t correct to one decimal place is 9.2. And it says here, by considering bounds, work out the value of p to a suitable degree of accuracy. Now, when it says by considering bounds, what we actually need to do is we need to work out both the upper bound and the lower bound for this calculation for p. So in order to do that, we need to first of all find out what the upper bound and lower bound values are for e. So I'm going to write down first of all e, and I'm going to write down what that value is, 812, and I'm going to just put that on a number line here, just to indicate what the next number would have been correct to three significant figures. It would be 813, and the previous number would have been 811. And then I'm going to determine my upper bound and lower bound for this value of 812 that we're given. Here's my upper bound, and here's my lower bound. So the lower bound value I can see here is 811.5, and the upper bound value would have been in between those two, which would have been 812.5. So I found my upper bound and lower bound for E. I'm going to go and do a similar thing for T. I'm going to go and write down what T is. T is 9.2. Okay, here just to understand that T is exactly the same T. We should have uppercase T here, so let's stick to the same notation. Uppercase T here, and the value of T here is 9.2. Draw a number line. The number before that would have been 9.1. The number after that would have been 9.3, correct to one decimal place. So the upper bound of those values would have been as follows. Upper bound would have been 9.25, and lower bound would have been 9.15. So now we've got the upper bound and lower bound values for both E and T. We're going to go and work out, because it doesn't say work out upper bound or lower bound for P, we need to go and work out both, because it says by considering bounds. So let's do that. We're going to find out what the upper bound for P is, so P upper bound. And how would we find that out? Well, to get a largest possible value for P, we want largest possible value on the numerator, so we want E upper bound. and we want smallest possible value for t, so t lower bound. So this would then give us p upper bound, which we've already got written down. So e upper bound is 812.5 divided by t lower bound, which is 9.15. And then if we do that calculation here, type that into your calculator, and we get, write down the full display, 88.79781 Make sure you always write down the full display that you get on your calculator, because we then need to do something with that later. But we're going to write down the p lower bound now. To get a lower bound answer for this, we need the numerator to be low. So we need lower bound here, and we need the denominator to be large, and that will then get us a small value for p. Okay. So what is e lower bound? Well, it's 811.5 divided by t upper bound, which we can see is 9.25. And then typing that into our calculator, we then get a value of 87.72972973. Remember to write down your full display. Now, we've written down the upper bound and lower bound value for p. We need to now consider, to a suitable degree of accuracy, what this value of p is. And what this basically means, this second part of the question here, by considering a suitable degree of accuracy, essentially means if we look at both the upper bound answer and the lower bound answer, to what decimal place are both numbers the same? So what decimal place are both numbers the same? Okay, to what decimal place are both numbers same? Both upper bound and lower bound answers the same. So first of all, let's look at if we rounded it to, let's say, one significant figure. Okay, we can look at decimal place, or we can look at significant figure here. We'll focus on actually significant figure, I think, because then we can, so instead of saying to what decimal place, to what significant figure are both upper bound and lower bound answers the same? So if I round to one significant figure, what would my number be? Well, my first number, upper bound, would have been 90, and the lower bound would be, so let's consider that upper bound would be 90, and what would be the lower bound answer? If I rounded that to one significant figure, it will be 90. So we can see here, to one significant figure, they are both the same, so that's fine. Let's see what happens if I rounded them to two significant figures. If I rounded them to two significant figure, my upper bound answer would have been, okay, what would my upper bound answer be? It would be 89. And what would be my lower bound answer? That would be 88, as you can see here. So you can see here I've got 89 for the top one and 88 for the bottom one. So to two significant figures, it's actually becomes different here. Okay, and if I did it to three significant figures, it would be 88.8 for the top one, and it'd be 87.7 for the lower bound. So it will start being different even more. So it starts being different now, and I'll just show you here. If I did it to three significant figures, what it would have been. It would have been 88.8 for the upper bound, and the lower bound answer would have been 87.7. So you can see that these numbers are different. Okay, they are different here, upper bound and lower bound. Upper bound and lower bound, again, are different for three significant figures. So when are they the same? They are only the same when it's rounded to one significant figure. If it was the same for two significant figure as well, then we would write that down as our answer, because that is more accurate answer. So then our final answer, we would say, is P is equal to 90. Correct to one significant figure, because that's when both the upper bound and lower bound are the same, because we're trying to find out one value for P, not an upper bound value, not a lower bound value, but just one value. So the only way we can get one value is if both upper bound and lower bound value are the same when rounded to the same significant figure. So one significant figure gives us the same value, whereas two significant figure doesn't. If two significant figure did give us the same value, we would write that down instead, because that would be more accurate. So you write the most accurate answer where both upper bound and lower bound answers are the same when rounded to the same significant figure. So our final answer here is P is equal to 90, correct to one significant figure.